Hey, what's up? It's Josh Wolf here from Magikcraft, and this is just something that I really loved doing as a kid, and so I recreated it using Minecraft and a bit of web programming. So on the Atari, which was the 8-bit computer that I had, you used to be able to do your own custom fonts. This was the computer I had. It was called the Atari 800XL. I'm using Dvorak these days, so it's a bit funky. Here it is, the Atari 800XL. That was the computer. And let's have a look at what the font looks like. You can get it as a custom font, but you used to be able to make your own custom fonts. There it is, the Atari font. Yeah, custom font. So you can make your own custom fonts. The Atari 800XL home computer. And the font that you used to be able to make. So it came with its own font, but then you could create your own custom ones. Yeah, it was kind of like this. This was cool. Make your own Atari Mania character generator. So I made this one in Minecraft. So if you go to font.magiccraft.io, I made an editor here that runs in your web browser. So this is how you'd do it. You'd create them on an 8x8 grid, and they were bitmaps. So it's a great way of learning binary numbers as well. So here's how you create a bitmap. You know, like let's do the letter A, for example. Just color them in like this. My friend had a Mac computer. It was the very first Apple Mac, and so he had a program like this in it. I used to do it on a piece of paper, and just draw them on squares. Now see, as I fill it in, like here it is as binary. So this is like blank, 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 colored in, blank, blank, blank. So that's 0, 0, 0, 1, 1, 0, 0, 0. It's a bitmap. And that binary number is equal to 24 as a decimal number. That looks kind of cool like that. And so what happens is each line gives you a number. And so you end up with 8 numbers because they're 8 bits across by 8 lines down, 8 numbers, 24, 60, 36, 102, 126, 108, 102, 102, 102. So those numbers are calculated by converting the binary into the decimal. And I might put the numbers across the top actually, so you can see where they are. So it's 1s, 2s, 4s, 8s, 16s, 32s, 64s, 128s. Down there like that. See if I put this here, that's 128. That one 64, that one 32, 16, 8, 4, 2, 1. So that's 8 plus 16, is it? Yeah, 16 plus 8, 24. So I've got all of the numbers here, and then I click copy. So now I got them. So I'm going to go over to my Magikcraft spellbook, play.magiccraft.io. And this is a spell that I wrote that takes those numbers, so you can see here. I put them into an array, and then I can write them in Minecraft. Let me see if my Minecraft's downloaded. Here we go. I'll show you this thing running. Launching. Got an updated version of Minecraft happening here. Mojang. So yeah, this is the spell. On the Atari, you used to do it by using peek and poke. So you would put all of those. Let's see if there's an article on creating custom fonts on the Atari. Create custom font. This thing here, the Magikcraft 8-bit font editor, it's just written in straight up JavaScript, no framework, nothing. I think I used Canvas and just straight JavaScript. Might rewrite it in Vue just for fun. Here we go. Atari Font Creator. Custom fonts. Anyway, you used to do it in BASIC, and you'd put the numbers into like a data statement and then poke them into the memory locations using loops. The way we do it in here is like we put them basically into a memory location by putting them into an array, and it's in JavaScript. It's what's called a keyed object, also known as a dictionary. I get rid of that, too slow. Sounds like Minecraft started because it's real noisy. Here we go, multiplayer. Connect to the Magikcraft server. What? Too small. Make it bigger. Okay, back to the game. It's nighttime. Switch it to day. You can see some words I've written down here. Okay, so the spell is called, I believe, _W I've called it. So if I go _W and I write something, say Josh, I don't know if you can do spaces. Underscores I don't know, just do Josh. Cast _W Josh. No, that didn't work either. Unknown command. Cast. What did that say? Oh, ABC. It's in the clouds. Let's go down. And let's try that again. Did that work? Nope. What's going wrong here? Let's have a look. Debugging. Let's try JOSH. Okay, that was a problem. I gotta convert the input to lowercase, I guess. Pretty cool. Haha. Let's try it like this. Josh was here. Haha. Ting. It's only done the first 4. What does it, run out of memory or something? Let's try Josh W. It's only doing the first 4 and then it stops. I think it might have run out of loops because there's a maximum number of loops that you can do. Anyway, here's the program that does it. I'm going to change it slightly, so I've got to change that input. Yeah, we should make them all lowercase. Make them all lowercase. Okay. Quit out of Minecraft because it's screen recording plus Minecraft equals slow. Convert string to array to get the for each method, but we should make it lowercase first. Let's Google it. Man, JavaScript lowercase. I think it's to lower. Like this. To lowercase method. Converts a string to lowercase letters. It's been in JavaScript since ECMAScript 1, so it's very old, been around for a long time. So you take the string and then you say to lowercase. There we go. Save. So inside my function I got all of these constants and then some like helper functions, and these actually don't need to be inside this function main because they're all like pure functions. They're all written as one-liners, and then I kind of wanted to make it so that each thing said what it does, so I'll run you through it here. So the first thing we do is we create this constant letters, and we take the word that gets passed in. So I was saying _W Josh, so that comes in as the word Josh, and that's why when I didn't put anything, it did ABC. Now, the first thing that we do now is we convert that word to all lowercase, because it was failing the first couple of times because I used the capital J and it doesn't understand capitals. So we make the whole word lowercase. Actually, this is kind of cool. I can show you how to sort of test stuff in here. So I bring up my developer tools. You know, I can go here and I go more tools, developer tools. It brings up, let's turn it back on. So here, more tools, developer tools. This is in Google Chrome, and I can go to console, and then in the console I can say something like, if I say const word equals and then quotes, and I can say Josh like that. And then if I say what is word, it's Josh. Now if I say what is word dot to lowercase, there you go, makes it lowercase, Josh. Okay, so let's move this over here to lowercase. So I make it lowercase, and then for each of the letters, oh yeah, I'll show you what array from does. So if we go const L word equals word dot to lowercase, and then if I ask it what's L word, okay, it's Josh. Now I go array dot from, and then L word, and there you go. It creates an array where it's got J, O, S, H in it. Now, what's cool about that is if I go const A equals array from L word, I can go A, and it gives me this array with 4 elements in it. Now I can execute a function on each of them. If I say A for each, so it's going to do it once for each of them. Let's say console.log. And here's what it echoes out: the letter, you know, the array element, the index, 0, 1, 2, 3, and then the whole array. So it gives you that each time. So what I do here is I go through each of the letters, and I don't worry about the whole array. It just passes in the character and the letter number. So J is 0, O is 1, S is 2, H is 3. So I need the number of the letter because that tells me where to draw it. And then obviously I need the letter because I know which letter I'm drawing. So the first thing that I do is I do this binary map thing. So I've got the letter J, say for the first one, and that's in char. So font data, char. So what I'm doing here is I'm looking up in the font data, which is my dictionary. I'm looking up the J, and there it is there, and it's 126, 126, 24, 24, 24, 216, 248, 112. So, you know, that's a J in this font editor, and you could reverse engineer it, but you can take my word for it. I should make a loader, actually, so you can load them. Anyway, so it gets the numbers, right? So now I've got the binary map from the font data. Now, that binary map is also an array. So if I go up and grab that array, J, this one here, copy that. Binary map, font data for each. So what I do is, I'm going to paste it here, dot. So I do for each on this array. So now what I've done is I've gone from a letter to, you know, some numbers that represent a drawing of the letter. And I'll do the same thing. I'll just pipe it through console.log so you can see what it's going to operate on. So here again, I got like, I'm going to get the line and the line number. So line 0, that's line number, has got 126. Line 1, 126. Line 2, 24. And you'll notice, that the first line or the first element is always 0 in computers, so it's called zero-based indexing. Line 2 got 24, line 3, 24, line 4, 24, line 5 has 16. Now again, I need to know which line I'm drawing, because that's going to tell me, where I should draw the line. So I'm going to draw line 0 at the top, and then if I'm on line 1, I'm going to draw that a bit down. If I'm on line 2, I draw that a bit down like that. So if you imagine I'm scanning across this and I'm drawing it, so this is line 0, draw it there. Now I'm on line 1, and it's like, let's say we were drawing A. I'm on line 1, so I'm drawing 60. So I'm going to draw, 2 blanks and then 4 blocks and then 2 blanks, but I'm going to draw them here. Now I tell the thing, you're going to draw a 36, which means, you draw 2 blanks, 1 block, 2 blanks, 1 block, 2 blanks, and then because I know I'm drawing line 3, I'm going to draw it like at this point. So we get the binary map. Binary map. What does binary map do? Binary map equals take the font char data and then map over the font char data, and then for each line generate a binary line. Oh yeah, so what I'm doing here is I've got the binary data, and then I'm going to go over each of the lines and I'm going to convert that number back into the ones and zeros. So binary map, to do that I do a binary line, so I take a line, and then I have to take a line. I'm going to create another array. Right, so I'm going to create an array of zeros and ones and add leading zeros. Okay, decimal to binary. So yeah, okay, so I'm going to stick the zeros at the beginning, but to go num to string 2. Oh, this is pretty cool. This is how I did the binary conversion. Let's say you have a number, like num to string. So take number. Okay, so if we take a number in JavaScript like 24, and I can say dot to string, and that's just going to convert it into a string. No? Okay. Maybe I have to do it like this? Yeah, okay. Weird. Not really weird, but I got to put those brackets around it, otherwise it doesn't know if I mean the 2 or the 4. I actually mean both. 24, the number. Okay, so if I make 240, it's going to return a string 240. I'll show you what the difference between them is. If I say 240 plus 10, what do you think that will do? 250. But if I say, if it's a string and I say 240 plus 10, string 10, it appends the two of them rather than doing arithmetic adding. So here's what's useful, is that I can take a number like 24 and then I can say toString, but instead of just calling the method, I can pass in the number 2. Now it's going to return the binary value of the string. There it is. And then I add some zeros to the beginning. Pad start. Is that a thing? Let's have a look. Dot pad start. Oh yeah, here we go. And then say add another. Oh, well, I say I want a total of 8. And I have to tell it what I want it to put at the start. I want it to put zeros. There you go. That's how I reconstruct the line. So I take the decimal number, I call toString, and then pass in 2 for binary, and I get a binary number back. And then to add the zeros at the beginning, I use pad start, tell it that there's going to be a total number of 8 cells, and that I want it to pad it with zeros. And then I got my first line of the A back, reconstituted from a 24. Okay, so now we're in here. So now we have an array, this thing, because if I do array from array from this thing, There you go. I now have an array. I'm going to do a space, a space, a space, a block, a space, a space, a space. That's how my drawer is going to draw it. So for each of these lines like this, which is an array, for each block, and then the block number, if this block here equals 1, then we're going to do the thing, which is store and transform the block. Now this is where, the second element, the letter number, the line number, and the block number, lets me know, if it's the second letter, then I need to add like the spacing for a letter. If it's the third letter, I need to add the spacing for 2 letters. If it's the second line, I need to add the spacing for the 1 line above. If it's the 4th line, I need to add the spacing for the 3 lines above. And same thing for the block number. If it's like, block number 4, then I need to add the spacing, space, 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 block, like that. And store and transform, what this one does is store and transform block. So to store and transform the block, that's the location. And we kind of start from, where the player is. So I grab here is where the player is, then I get their X, Y, and Z. And then we use the X, Y, and Z here. And I'm basically scanning along, and then store and transform block means I store the block, and store block is up here. I push it into an array of blocks, and transform the block. And transforming the block means that I set the type to the block type. So in here, if I'm doing a interesting. So for 0 blocks, which is a space, I do nothing. I don't actually create a space. I just skip over it. So only in cases where I need to put a block in will I put a block in. So what that means is that you can't carve things out with this. It's not gonna wipe out any of the blocks that are there. It just won't put anything in there. Let me restart this thing and then show you what that looks like. And then the store and transform, so I've stored them, I've transformed them, and then what happens is I set a timeout for however long that persist seconds is set to, which is, I don't know, maybe 5 or something. Let's have a look at the top. Persist seconds, where are you? Oh, so slow once Minecraft starts. God. Hopefully the new spellbook is faster than this. 10 seconds. Now what happens is that after the 10 seconds is finished, it's going to transform the blocks back. So I store what the original block was so that we can undo them after 10 seconds. That's obviously not working, because those are not disappearing after 10 seconds. I'm not sure why. But let me show you what happens. So it's writing in that direction there. So I'm going to write something right through here, like this. Cast _W, and we should be able to use capital letters now. JOSH. There we go. Okay, so let's try running that again here. Bam! There you go, went through the cliff. Got to get it more on the court like this. Haha. Here we go. Dook. Now that, my friends, just went right through that cliff. So you can see here that it's probably a good example here. No, not really. Yeah, it is a good example. So you can see here that there's a space in here, but it didn't carve out a space there, nor did it carve out that space there. It's just wherever there was, wherever a block should go, it puts it in, but it doesn't actually add the spaces in. It just does not write anything there. Could make it put spaces in. Dude, got my name everywhere. Graffiti artist. Wonder why the store and transform is not working. Set a timeout. Yep, and then say that. So this timeout doesn't seem to be working. Interesting. Let's do this. Kind of a little bit of debugging here. So we'll say magic Dixit setting timeout. Oh man, my typing. Goodness. Setting timeout. Save. It did not say setting timeout. So that code is not getting run for some reason. What happens if I make it just 3? Setting timeout. Okay, it's like it runs out of a... That will disappear after 10 seconds. Yeah, see that? Didn't disappear all of it. It's like it's running out of memory or something. See, it wrote that. It's going to set the timeout and it's going to disappear, but it's not going to disappear all of it. It's like it couldn't store that last part there. Wonder where and how it could be running out of memory. Disconnect. Close. For each letter, for each line, for each block in the line. Maybe it's, yeah, it seems like it's running out of memory. I'll have to look into it further. Anyway, that's enough for today. I'm going to keep playing around with this and I'll keep explaining it and coming back, and I'm going to do some refactoring to make it clearer, maybe build it up from first principles from nothing. And so anyway, font.magiccraft.io for the font maker, and play.magiccraft.io for casting the spells and writing the spell, the editor, and magiccraft.io for the Minecraft server. Have fun.